Ladies and gentlemen, welcome to this tutorial on pure mathematics on the topic trigonometry. Today in this tutorial, we are going to solve the pertinent questions under trigonometry for the past GCE sessions. We are going to begin with June 2023, paper 2, question 5. And so that was the question on trigonometry, which reads, question 5, Roman 1. Solve the equation cos of x equal to sine 2x in the interval of between 0 and 2 pi. Roman 2. Express 5 cos x minus 12 sine x in the form r cos x plus alpha, where r is bigger than 0 and alpha is in that interval, giving your value of alpha correct to 1 decimal place. Hence, or otherwise, find the minimum and maximum values of 10 over that. So we are going to get started with Roman 1. Here we are going to solve this equation. Solution. Solving the equation cos x equal to sine 2x. Cos x equal to sine 2x. Now, this is what we are going to do. You remember we can use a double angle identity to resolve this. And so we know that sine 2x is equal to 2 sine x cos x. Alright, so we're going to fit it here, and we have that cos x is equal to 2 sine x cos x. And from there, we now have that 2 sine x cos x minus cos x is equal to 0. And so we can factorize out, we factor out cos x. Cos x here, we're going to be left with 2 sine x minus 1 equal to 0. Okay. And so from here we have that either cos x is equal to 0 or 2 sine x minus 1 is equal to 0. And if cos x is equal to 0, it means that x, we are going to have here the principal values, the PV. And the principal value here is going to be the cos inverse of 0. On the other hand, it's going to be the sine inverse of half. How come? X here, from here we have that from 2 sine x minus 1 equal to 0. We have that sine x is equal to 1 on 2. And so x is the sine inverse of half. Okay. Now, the cos inverse of 0 is pi on 2. Meanwhile, the sine inverse of half is pi on 6. Here we have the principal values, and we are going to proceed with the general solution. Come inside. Run. 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 So let us proceed with the general solution. So we are going to have the general solution of the cosine general solution, and then that of sine x. The general solution GS will imply that x is equal to, yes, we're going to have two solutions. For the cosine function is 2 pi n plus or minus PV. And PV here is the cos inverse of 0 plus or minus cos inverse of 0. It is pi n plus negative 1 to the power of n times PV. And PV here is sine inverse of a half. So now, that is it. We now begin to substitute values of n. Let n to be first of all 0. For n equal to 0, we're going to have that x is equal to, we put 0 here, it vanishes this, then we just have plus or minus cos inverse of 0. That's pi on 2. But we need this value in the interval that was given to us as being positive between 0 and pi. Exactly. So we are going to take just the positive value of pi on 2. We fit 0 down here, and so we are going to have pi on 6. Pi on 6. Yes. We are going to have, this one will be 0, this one will be 1. Then sine inverse of the half is pi on 6. Then now we fit n equal to 1. For n equal to 1, directly we are going to have, let me see, we're going to have, here, we're going to have pi minus pi on 6, x is equal to pi minus pi on 6. And this gives us what? 5 pi on 6. Now, let us recall the value of our interval that we were given. Let's record the interval I was 0, x between 0 and pi. This is the interval that we had given to us. So I'm summing that interval, and so x that belongs to I include x equal to pi on 6, x equal to pi on 2, and x equal to 5 pi on 6. So here is the general solution of this trigonometric equation. Now, in Roman 2, they say express 5 cos x minus 12 sin x in the form r cos x plus alpha. Roman 2. So we are in Roman 2 now, and we have that f of x is equal to 5 cos x. 5 cos x. Let's let f of x be that 5 cos x minus 12 sin x. Good. And then we have to express it in the form r cos x plus alpha. So now, comparing with f of x, we have that the coefficient of cos x here is r sine alpha. So we have that r sine alpha will be equal to 5. We name that equation 1. The coefficient of cos x is r sine alpha. The coefficient of cos x is r sine alpha, and the coefficient of sine x is r cos alpha. So you have r cos alpha. That will be 12. Equation 2. Now, first and foremost thing, we can square equation 1 and equation 2. So let's have equation 1 squared plus equation 2 squared. Yes, so we have r squared sine squared, we have r squared into sine squared alpha plus cos squared alpha is equal to 5 squared plus 12 squared. That will just give us 169. Then now, Sine squared alpha plus cos squared alpha will be equal to 1. So we are left with this, that r squared is equal to 169, and we have that and r is equal to 13. Normally r is equal to plus or minus 13, but now it said but r is bigger than 0. It was said in the equation, so we now have to take just the positive value of r being 13. Now what is the next thing we can do? Divide equation 1 by equation 2. So let's take equation 1 divided by equation 2, and this gives us that r tan alpha is equal to 5 on 12. Yes, 5 on 12. And from here we're going to have that we know the value of r as 13. When we divide equation 1 by equation 2, r cancels off. So we are going to be left that tan alpha is equal to 5 on 12. Sine alpha over cos alpha is tan alpha. R cancels off. Now we have that we have that sine alpha over cos alpha, which is tan alpha, is equal to 5 on 12. And so alpha is equal to tan inverse of 5 on 12. Mathematically, this gave me 22.6 degrees. After having the value of r and alpha, now we have to express that in a form r cos x plus alpha. So it is going to be first r 13 cos x plus 22.6 degrees. So this is how we're supposed to express it. Now the question continues, hence or otherwise. Stop. So we have that f of x has been expressed as 13 cos of x plus 22.6 degrees. Very good. Now the question continues to say that hence or otherwise, find the minimum and maximum values of this. We recognize that function in the denominator with the absolute value is our f of x. It's our f of x. So, and then this is a cos function, and the cos function is bounded. Cos is bounded. The cos function is bounded between -1 and 1. So it means that the this function will exist between -1 and 1. So we are going to have that -1 less than or equal to 13 cos x plus 22.6 less than or equal to 1. Now, sorry. So, since it means that we are going to have that -1 is less than or equal to the cos of x plus 22.6 degrees less than or equal to 1. Now from there, let's multiply all through by 13 because of this, so that we can have 13 cos here. So I have -13 less than or equal to 13 cos of x plus 22.6 degrees less than or equal to 13 here. We have multiplied everywhere by 13. Now, the next thing, this is already our f of x, and the next thing we need to do now is to take the absolute value. When you take the absolute value of any function, that function must always be positive. It means it must always be greater than 0, always positive. Alright, so bigger than or equal to 0, something of that sort. So now we're going to have 0 here, less than or equal to the absolute value of this function, 13 cos of x plus 22.6 degree, less than or equal to 13. So when you take the absolute value of this function, it must be greater than or equal to 0. At least it must be negative. So that's what happens. Alright, when we look down there, we see there's an addition of 15 to our function. So we're going to add 15 to both sides. We're going to have that 15 is less than or equal to the absolute value of 13 cos of x plus 22.6 degree, absolute value, yes, less than or equal to, sorry, I'm adding 15 plus 15, absolute value plus 15, then less than or equal to 13 plus 15. Okay, right now, what is 13 plus 15? I think it's 28. 13 plus 15. 13 plus 15 is what? 28. 28. So right now, I'm going to take the reciprocal, mean that I'm going to take 1 over that. So I mean I'm going now to have that implies 1 over 15 less than or equal to 1 over absolute value 13 cos x plus 22.6 degree, yes, absolute value plus 15, less than or equal to 1 over 28. Then I'm saying 10 at the numerator, so I multiply all through again by 10. So now I get that 10 over 15 less than or equal to 10 divided by 13. After 13 cos of x plus 22.6 degree, absolute value plus 15 less than or equal to 10 over 28. I simplify it now. 10 over 15, I can simplify here by 10. So I have 2/3. I'm going to have 2/3 less than or equal to 10 over absolute value of 13 cos of x plus 22.6 degree plus 15. Then less than or equal to, I simplify this by 2. I have 5 on 14. So that is just it. I'm going to have this as the minimum value and this as the maximum value, because I am asked to find the minimum and the maximum value. So it means that the minimum value is equal to 2/3 and the maximum value is equal to 5 on 14. So here we complete the solution to June 2023. Thank you for watching. We take a small break, a 5-minute break, and then we move on to 2022. So while waiting for 2022 coming up, subscribe to this channel for more video notification. Thank you for watching.